Today we are going to be talking about applications of trig. So we are still only going to be using sine, cosine, and tangent. We're not going to use any new trig equations today, so just the three that we've already learned. But we're going to be putting it into a context. One thing students always ask in math classes is, when are we ever going to use this? And trig is one of those things that is extremely applicable. So today we're going to look at some ways that it could be used, particularly in measuring. So it says, suppose an operator at the top of a lighthouse sights a sailboat on a line that makes a 2-degree angle with a horizontal line. And then we have a definition. It says this angle between the horizontal line and the line of sight is called the angle of depression. At the same time, a person in the boat must look 2 degrees above the horizontal to see the tip of the lighthouse, and this is called the angle of elevation. Find the distance from the boat to the lighthouse if the top of the lighthouse is 25 feet above sea level. Our strategy is always going to be step 1, draw and label a diagram or picture. For a couple of your homework questions, they will give you a picture, but for most of them, you will need to read the question and draw a picture. Your picture will always have a right triangle in it, because that's how we do trig, is with right triangles. Then step 2 is, based on what we know and want to know, choose the trig ratio to use. So are we going to use a sine, a cosine, or a tangent? And all of them are fair game. And then step 3, solve it using a calculator the way that we've been practicing the past couple days. So for this question, start by drawing a picture. So you can draw like a picture if you want. I'm not good at drawing. So when I draw a lighthouse, there's my lighthouse. Okay? I don't draw a lighthouse, I just draw a triangle. And I know that that is my lighthouse standing there. Then it says, they see a boat. Okay, well, I can draw a little sailboat here. So there's my little sailboat. You don't have to, you could just draw a point. It doesn't matter. What we need is a right triangle. So there's a person at the top of the lighthouse that looks down here and sees this boat. And it says that when they do so, they make a 2-degree angle with the horizontal. So what that means is, if this person in the top of the lighthouse looked straight out, then to look down and see the boat, they only have to look down 2 degrees. So that's where an angle of depression belongs. Is think about standing from the top and looking straight out, and then how far do you need to look downward to see what you're looking at? And that looking downward is that angle of depression. Then the question says, likewise, if the person in the boat wants to look up at the lighthouse, they're going to look up 2 degrees. Now in this question, those two angles happen to be the same thing. And that lower one was defined as the angle of elevation. So in this question, the angle of depression and the angle of elevation are the same thing. Do you think that's a coincidence, or do you think that will always be true?
Always.
Why? Can you give me a good geometry reason?
Because
AIAs. We've got 2 parallel lines there with the 2 horizontals at the top and the bottom, and those 2-degree angles are alternate interior angles of each other. So your angle of depression will always equal your angle of elevation. The angle of elevation is more useful because it is inside of the triangle that we're going to be working with. So if in a question you are given your angle of depression, just draw it in as your angle of elevation. Okay? They're the same thing. An angle of elevation is more helpful because it's in the triangle. Okay. Then our question said, find the distance from the boat to the lighthouse. So this is our x. Where does it belong? The distance from the boat to the lighthouse. It's the bottom line there of how far would that sailboat need to sail in to reach the lighthouse. If the lighthouse is 25 feet above sea level. So where does that belong? On the height of the lighthouse. Okay, so we begin by drawing a picture. Then, based on what we know in the picture, so we're going to use this 2-degree angle. We want to know x, and we know 25. We have to pick a trig function. So according to that 2-degree angle, what kind of a side is 25? It is an opposite. What kind of a side is x? It's an adjacent. Which trig function uses opposite and adjacent? Tangent. So we're going to say tangent of 2 is 25 over x. We had this happen in some of our problems last night as well, where the variable's on the bottom. It's a little trickier to solve, but not impossible. It just takes 2 steps instead of 1. We're going to multiply both sides by the x. And that clears the fraction, but the x is still not alone. So to get the x alone, we divide by the tangent of 2. So in the calculator, then, we do 25 divided by tangent of 2. And what do we find for x? About 716 feet. Now that seems like a really big number. So it's always a good idea to make sure that this answer is plausible. The lighthouse is only 25 feet high. So our answer is a whole lot bigger than the other side. I would say this answer still makes sense, though, because that person in the boat is only looking up 2 degrees, which is hardly at all. So if you're really close to something and you're trying to look up at it, you have to turn your head a lot, right? But if it's really far away, you don't hardly look up at all. So if they're only looking up 2 degrees, they must be really far away from this still. So that makes sense as an answer then. Okay, so after you get your answer, it's always a good idea to kind of make sure that it makes sense in the context of the problem. If it doesn't, that might clue you in that you did something backwards. Questions? Okay, I have another drawing for you where we're going to practice these vocab with angle of depression and angle of elevation. Okay, so this question says we've got an airplane, so that's our point A, and we got 3 people standing on the ground at X, Y, and Z. What is the angle of depression from A to X? What is the angle of depression from A to X? So if there's a person in the airplane and they want to look at person X, it would be 23 degrees. The angle of depression from A to X would be 23 degrees. What about the angle of elevation from X to A? If person X looks up at the airplane, how far do they need to look up? 23 degrees. A depression will always match an elevation. What's the angle of elevation for person Y to A? 35. So then if person Z wanted to look up at the airplane, do you think their angle of elevation is going to be larger or smaller than the other guys?
Larger.
Why?
Closer.
He's closer, so we'd have to look further up. We can also look at the progression of 23 to 35. We're getting bigger as we get closer to straight underneath it. If we were exactly underneath it, we'd have to look up at 90 degrees. Okay. All right. So now let's do a practice problem solving a triangle. So again, here's some of my awesome art skills. We're going to have a hill, and on top of the hill, have a little guy getting ready to go on a toboggan. And we're going to pretend, even though hills aren't really like straight lines, we're going to pretend like this hill is, a fairly straight line. Okay. So our word problem here says, a toboggan travels from point A at the top of a hill to point B at the bottom. Because the steepness of the hill varies, the angle of depression is only going to be approximate. So it says, let's just kind of pretend like it's a straight line, even though hills aren't really straight lines. If the toboggan travels 130 meters downhill, okay, where does that 130 meters go? That's the hypotenuse. It went 130 meters. That's how far it traveled. That's the hill distance, the hypotenuse. And the vertical descent is 50 meters. Where does that go? Under A. It's that vertical height. That's how tall the hill is. What is the approximate angle of depression? So an angle of depression, if I want to draw an angle of depression into the picture, that's this guy at the top looking straight up, and then how far does he have to look downhill? That's the angle of depression. That's not particularly helpful to draw in there because it's not in my triangle then. So where could I put it that it would be in the triangle? Down by B is going to be the same. An angle of depression and an angle of elevation will always match. So we have our picture now. So that's step 1. Step 2 is figure out what we have and which trig function we'll use then. So according to x, what kind of a side is 50? Opposite. And you guys told me 130 was the hypotenuse. So which trig function uses opposite and hypotenuse? Sine. Sine of x is 50 over 130. And how do we solve that? Second. When we're solving for an angle, we do our second. So this is where we're going to go second sine 50 divided by 130. And how steep is that hill? About 22 or 23 degrees. It has a 22 or 23 degree grade. Okay?
Wait, what?
Questions? All right, your homework is 1 through 8. 1 and 2, they give you pictures. The rest, you're on your own.